Hi everyone, Professor Bob Young here, and we're going to wrap up factoring in this instructional video looking at just some general rules for factoring virtually everything that you have encountered so far. So hold on, it's going to be a wild ride here. Now, in your supplemental notes and handouts and so forth, you'll find an angel. You'll see this handout, which I kind of put in a landscape versus a portrait mode that y'all have on yours. It's called General Rules for Factoring. So we want to go ahead, if you're going to factor anything, this handout I think will really help you out here. All right, let's run through it real quick. Now, number one in this, I don't care what you're factoring, trinomials, grouping, binomials, the first and foremost rule of factoring is to always take out that greatest common factor first, if it has one. All right. Now, after that, let's kind of go down the line here. And I just like to categorize things by how many terms. Like binomials with 2 terms, you want to look for a couple things on these. Once you take out any greatest common factor, you want to look for, our friend, the difference of 2 perfect squares. And I gave you the general formula here. A square minus b square factors into conjugates a plus b times a minus b. And I gave you a whole bunch of different examples here of what the difference of squares will look like. And again, we're to the point now, ladies and gentlemen, where recognition comes into play. Do you recognize these things, the difference of squares when you see them? Also, if it's got 2 terms, you may have the sum or difference of what's called 2 perfect cubes, and hopefully you've looked at that cube video there, and these factor the cubes a cubed minus b cubed and a cubed plus b cubed factors into binomials times trinomials, so you have to kind of have those general formulas down. And again, would you recognize perfect cube numbers and variables if you saw them? Remember, perfect cube numbers, take a number and cube it, it's a perfect cube. Variables divisible by 3, as you can see in those examples. All right, so that takes care of 2 terms, but what about trinomials with 3 terms, Young? Well, the easiest way to factor a trinomial is first look and see if it's a trinomial square. Now, what's that mean, Young? Well, the first and last terms are perfect squares. So again, perfect square numbers, you can take a number and square it, gives you a perfect square variables divisible by 2. So you can see here that these 3 examples lend themselves to a trinomial square. And whenever you factor one, remember, you usually get 2 of the same things. And we're going to do some examples here and kind of refresh and so forth. And also, if it's a trinomial, remember, if a trinomial in this form, it's called quadratic form, will factor, the factors of a times c will add to give you the middle number b. So you can use these rainbow numbers here, as we call them. A times c, factors of those are called rainbow numbers. And you can split this trinomial into 4 terms. All right, the b number into 4 terms, and then group it if you want to. That's why this is called, by the way, ladies and gentlemen, quadratic form, because you can take a trinomial and break it into 4 parts, the quad word. And speaking of quad in 4 terms, let's look at number 4 down here. When factoring 4 terms, look to factor by grouping. So arrange the polynomial in descending order, and then always be sure to separate your groupings with that plus sign in the middle. So you'll go ahead, notice on this first example here, and as these get more difficult here, I went ahead and arranged it so this was in descending order and then grouped the first 2 and the last 2. All right, as I did in the second example down here. And remember, this is the big leagues. You'll also have some of these grouping problems where it may not be the first 2 and last 2 that factor. It may be the first 3 or the last 3 that factor. And I gave you some examples what to recognize again there. So we're going to have to start seeing if y'all recognize some things starting right now. All right, first and foremost here, we're going to look at a binomial. 50x squared minus 18y squared. And I know what some of you are thinking out there. Now, hold on a second, Young. This doesn't look like anything I've seen before. It doesn't look like the difference of squares. Those aren't perfect square numbers. But again, what is that first and foremost rule of factoring? You forgot it? Let's back up. Oh, the GCF. Young, you're slipping in a little bit tougher ones here in this last video. So what we're going to do is I see that 2 will go into each of those 2 terms in the binomial, leaving me with 25x squared minus 9y squared. And how could you check that? You could distribute and it would check. And ladies and gentlemen, there it is. I see the difference of 2 perfect squares. So you will get 5x plus 3y times 5x minus 3y, the conjugates. And there is your factored answer. Now remember, when you take out that greatest common factor, do not forget to include that as part of the answer, because all of these 3 things must multiply back together, and you can check any factoring by multiplication to get back to where you started from. So it's kind of nice. All right, I'm going to go different colors on some of these. Example 2, do y'all see a greatest common factor in this trinomial? I do. 2y is a common factor. So when you take 2y out of each term, you're going to be left with 9y squared. And remember, you can take that common factor if you want, and you can put it right under each term of the trinomial to make it a little bit easier here, plus 6y plus anything divided by itself is 1. And that's the answer, right? No. Do you recognize this is a trinomial? What's that called again? Trinomial square. First and last terms are perfect squares. Now, it may or may not be, but it sure looks like it lends itself to 1 if you see it. All right, so let's see when this factors here, we're going to get, well, what 2 of the same terms give me 9y squared? Well, how about 3y, signs in both? Remember, we're going to get 2 of the same things here, both pluses. Why? Well, because both of these are pluses, and no one better miss the last 2. What times what gives us that 1? 1, 1. If you FOILed this and this, would it give you this? Check it, yes. And then if you multiplied it back by the 2y, you would get right back to where you started. Check all factoring by multiplication. Final answer, 2y, let's write it like we do in the big leagues here, times the quantity 3y plus 1 quantity squared, since there's 2 of them. All right. So we are getting down to some nitty-gritty here. Some more examples. You know, Young, he likes to give you lots of examples. Go with different colors here. Does this trinomial factor? Well, let's see here. 1 times 5 is 5. I need factors of 5. Let's put 1 and 5 here. I don't know any other factors of 5. Now, can I get 4 out of this? Yeah, I could put a what here? A minus 1 and a plus 5 here. But wait a minute, this minus 1 and plus 5, I don't see any negative signs in here at all. So I could keep trying to factor this, but ladies and gentlemen, this trinomial will not factor. It is prime. All right, so in order for this to have factored, both of these signs would have had to be the same. Now, if you tried to split that in 2 by grouping, we may come back to that and look at it, or you may try it yourself, but it will not factor. I'm sorry, not everything in life factors. Young, you're just being evil here on this one. All right, let's try this next trinomial. I see something in common here. I see you could take out a what? A 6. No, 6 doesn't go into 21. Let's just back up on that. I like reversing field here. What does go into? Wait a minute, how about 3? See, so sometimes you may not get the right number. 3 goes into all 3 of those. X squared. And let's see what's left in here. 6x squared plus 7x plus 2. Let's distribute and check this and make sure it works. Okay, that gives me 18x to the 4th, excuse me, 21x cubed, and 6x squared. Looks good. And we're done, right? Well, let's just see if we're done. 6 times 2, factors of a times c is 12. Anyone know any factors of 12 that will give you 7 in the middle? 3 and 4 will, and both of those signs would have to be pluses, pluses. And since we have pluses, pluses down here, this is looking good. So again, now here's what I'm saying, be careful of. When you have a greatest common factor, and we know that trinomial probably is going to factor in this case, take this and move it down here. Get it out of the way so it doesn't mess you up here. And we are going to put 3x squared down here. And then we're going to continue factoring this trinomial here by grouping. So we're going to just go ahead and break this trinomial into 4 terms, putting plus 3x plus 4x plus 2. So again, that's why it's called quadratic form, because you can take 3 terms and break it into 4, and then we can group it. Make sure you leave that plus sign in the middle. And remember, when you factor by grouping and you do it correctly, I think you'll see some greatest common factors in each one of these. In the first 2, you could take out a common 3x. What's left? 2x plus 1. The second 2, I hope everyone sees, you could yank a 2 out of, 2x plus 1. And if you do it right, you will get this common creature here, a bi-bi, I call it, a binomial with a binomial in common. What does it have in common? You could yank out a 2x plus 1 and then put the 3x plus 2 as the final answer. Don't believe this will work. I bet you if you FOIL this and you multiply that FOILed product by that 3x squared, it will get you right back up there where you started. So always check these things, and you can never miss one. All right? Now, I know what y'all are thinking, Young, why couldn't we have done that up top up here? Why couldn't we have taken this x squared and said minus x plus 5x plus 5 and done the same thing? We could have taken this 4x here. We said this was prime and split it using these numbers, but watch what happens when you try this. If it's prime, it's not going to be pretty, ladies and gentlemen. You're going to say, okay, well, I can take an x out of here. I'll show you, Young sucker. And you'll put x times x minus 1, and then you'll go, then I can take a 5 out and put, wait a minute, I don't get anything in common. And then here you'll go, this is not the bi-bi, it just ain't going to happen for you. So you can try any combination to factor it, but if you go to multiply and check it, you will never get that trinomial up top back. All right, let's bring it home. Now, these last 2 examples. Our friend, the difference of 2 perfect cubes. You must recognize that, ladies and gentlemen. And when you do, you're going to come over here and write that a cubed minus b cubed formula. And you're going to say, well, that breaks apart into a binomial times a trinomial. So a lot of this is recognition. Students are always telling me, Young, I need to memorize all of these things. You can't memorize it. You just kind of have to recognize it and practice it enough until it all unravels for you. So remember, the binomial part starts out a minus b. If you looked at the previous videos, you get an a square and a plus b square here, just like you do when that's a plus in the middle there. And then, what do you have in the middle? A plus ab. All right, so this is those problems where you take and you break these cubes in this problem into what Young calls the cubic component. So if we're looking at 8x cubed, what do I put in this first parentheses? What times what times what? 2x times 2x times 2x will give me that 8x cubed. For the second one, no one better miss this one. Y, right, will give you the y cubed. So now, wherever I see an A, I'm putting in 2x. Wherever I see a B, I'm putting in y. You just have to practice them enough. So let's go down the line here. A, 2x minus b, y. Never mess with those signs in there. Parentheses here. A squared is 2x, and I'm showing my steps here, squared, plus A times B is 2x times y, plus B is y squared. So again, and I keep reiterating this on these, never, ever, ever, when you are factoring cubes, mess with these signs, or your grade will get messed with. All right, final answer. Equals 2x minus y. Here's the binomial part. The thing you want to be careful of on all of these cubes here is when you square something with more than one thing in it, that 2x times 2x, dangerous again, 4x squared plus 2xy plus y squared. Could you check this on the test and make sure? Yes, you could actually multiply this binomial times the trinomial, taking the 2x, distributing it through, taking the minus y, distributing it through. When you collect like terms, you will get back there if you did it right. And for the final example on factoring, just general rules here. This fourth problem here, or this bottom last problem, it looks like a grouping problem to me. Now, it's not just any grouping problem. On this one, you could try doing the first two and the last two. You could try rearranging it, doing the first two and the last two. Ladies and gentlemen, it will never work unless you see that first three terms is, what's that called again? There was some name for it. What's this thing here? A perfect square trinomial. And this will factor into two of the same things if you recognize it. Do you see what I see? In factoring, you must. XX minus, but 7 would give you that trinomial square. Would it FOIL and check? You betcha. Let's keep going here. Ladies and gentlemen, we're not done yet. Let's write this sophisticatedly. X minus 7 squared minus 9y squared. We have the difference of two perfect squares. What a beautiful problem. We had a trinomial square here, I'm going to abbreviate that, which led to the difference of two squares here. It's bringing tears to my eyes. Now, how do you factor this? I'm going to put some brackets in here since we have parentheses on that square there. And this is how they do some of these more extravagant ones. So to get x minus 7 squared, you would put x minus 7 times x minus 7. And if you want to, you could put first powers on those because remember, power rule number 1, chapter 5, going way back, whenever you multiply same bases, add the powers. It may be a different chapter in your book by the time these videos go, who knows? Plus, minus, but 3y. Now, since anything to the first power is itself, here's how they'll write this answer. X minus 7 to the first is just x minus 7 plus 3y times x minus 7 minus 3y. Could you check it? Yes, you could multiply these two trinomials and it would get you back to where you started. So always check factoring by multiplication. Bob Young signing off. Be able to factor anything from now on the rest of your life.